Hey folks, how's it going? My name is Rosendo Pili from Major League Hacking. I am super thankful for all of y'all being here this morning or this afternoon or this evening or whatever time of day it is, and from whatever part of the globe you're joining us from. I'm really excited to be here and to introduce a wonderful guest that we'll be having doing a presentation. Her name is Captain Laura Curro. She is currently working at the United States Air Force. So, she has some things to tell you about some tech opportunities there and what she does on a day-to-day basis. So without any further ado, I'll go ahead and add her to the stream and let y'all hear what she has to say. Thanks a lot, y'all.
Hi, can you hear me?
Yes.
Great, thank you. Thanks for the intro, Rosendo.
Sure thing, I'm gonna drop off.
As you said, I am Captain Laura Curro. Hello, everyone. Nice to meet you. And today I'll be talking about what I currently do in the Air Force right now. Is my screen share working? There we go. And the things that I'm doing for testing as part of my job. So for the occasion, I picked a lovely XKCD comic because there's an XKCD comic for everything. And with that, let's get started. So as an overview, I'll tell you a little bit about myself, my career path through college and the Air Force, go into red team capabilities, which is what I'm working on, talk about the project we're working on, Rebellion, my efforts in testing with it, and then some of the future work that I hope to do with the project. So for my career path, I graduated from Rensselaer Polytechnic Institute in 2015 with a Bachelor's of Science in Computer and Systems Engineering. While there, I commissioned with the United States Air Force as well. And during the summer there, I also did a program called the Advanced Course in Engineering in the summers of 2014 and 2015. If you have heard of that program and want me to talk more about it, you can do so later. After commissioning, I went to the 333rd Training Squadron for my initial cyber training. It's called the Undergraduate Cyber Training. They go over the basics of networking, offensive cyber operations, defensive cyber operations, and different things like that. From there, I took my first assignment, the 346 Test Squadron, which is when they put this test stink on me, and I've never gotten rid of it, which led me to my current job now, where they're like, hey, we heard you had testing. And I was like, you're correct, I do. There, I had a few different jobs as an offensive cyber operations range lead, cybersecurity lead for a project, and then as a test developer working with our sister squadron, the 90th Cyber Operations Squadron. In 2019, I left there and I came to this Computer Network Operations Development Program where I'm at now. This is one of NSA's development programs for its civilians. So when they get new hire-ons, they put them in a development program, which give them different tour options that they can look at throughout the program for 3 years before they can finally settle on the job. The military looked at this and said, hey, we see that this is some good training, these are some good opportunities. Let's send a few military people there and get the training. And I'm one of those military people. So I'm not part of the NSA. I'm still with the United States Air Force, but I take a few tours in their offices right now, working different jobs. So that's a 3-month program that I'm in right now. I'm in my second year. I started out doing 3 months of core training where they taught me the basics in programming in Python, C, reverse engineering, a bunch of different operating systems, assembly languages, networking, and coding. And then while here in the program, I've had a few different jobs in natural language processing research, media fraud detection, and finally where I'm at now in red team capabilities. So where I'm at in red team capabilities, we make things for red team. As a quick overview of what red team is, if you're not familiar with it, it's a way of red team and blue team. There are two things that improve the cybersecurity posture of an enterprise. Blue team looks at things from a more passive standpoint. It'll do things like vulnerability analysis, looking at different code, different software that's installed, and see if there's any vulnerabilities on them, looking at what ports are open, if there's any way to exploit those, different things like that. Red team takes a different approach and it's much more active. So now red team is going to emulate an adversary's capability. They're going to take what the adversary techniques tactics, procedures are and try and use them against the system. Full disclaimer, this is done with the customer's understanding in mind. This is not to be done without their permission. That is illegal. You do this with full cooperation of the company that you're doing a penetration test on. The point of this, again, is to improve the cybersecurity posture and demonstrate with what an adversary might actually do, what the impact of the mission might actually be. At Red Team capabilities, again, we make capabilities for Red Team. This is largely through using open source tools. So we'll scour the internet and say, hey, this looks like a new capability that people might use. Let's see how we can incorporate it into our penetration testing. So after incorporating a lot of different open source tools, it became a pain for operators to have to learn a new tool every time. And so they made a system called Rebellion. And what Rebellion does, it combines all of these open source tools and provides one user interface for it so that you only have to learn one set of commands, and then frameworks will interface with the open source tools to actually talk with them. So now instead of learning a whole bunch of things, you learn one thing. Much easier for people. Their lives are much happier. So going over the diagram in front of you a little bit, on the left side in red, we have how the operators interface with the system. This is done through either a GUI application, Red-Eye, which is a website that they'll go on to interact with things, or the command line interface TUI. The Rebellion team server itself in the middle in gray consists of three things, which is a Postgres database, the Rebellion application itself, which has all the code for managing all the different frameworks into it, all the listeners, everything else that'll be a part of it, and then the different frameworks that are attached to it. And the frameworks themselves are just a translator that are connected to each tool, each open source tool. And this is a Rebellion command, this is an open source tool command. Let's connect them. And then on the right side, we have the remote servers in blue. And these are the different targets with agents on them specific to each of the open source tools. Questions on that so far? No? Okay. So getting into a little bit of how this might actually work when you run it, we have the team server, and this will set up two things, a payload and a listener. The payload will be deployed to the target computer and will be run, it's usually some kind of binary, will be run on that computer to give you administrative access to it usually. On the team server side, we'll actually set up a listener, open up a port and say, hey, listen on this port for a payload to connect back to it. Once they've connected, you now have an agent on the target computer that you can send commands to and get responses back from. And now you can do things like say, hey, agent, get me Etsy Shadow on this computer, and I can then start cracking passwords. Or, hey, I want you to give me a list of processes on the computer, so I can look to see what programs it's running and see if I can exploit any of them. Whatever you need to do. So now that we have how it works, there's a little bit of difference in who's working on what thing. The team server itself, the main component for Rebellion, is handled by the main core developers at Red Team Capabilities. These are people that work here full-time. In the middle, working on the frameworks, are people like me, interns that come through for 6, 12 months at a time to just work on something and then probably gone. On the other side, we have the remote access tools from open source that we have no control of the development of. I have no idea who these people are that are developing this. They don't work for us or anything. They're just something we found online on some GitHub that looked cool. We thought we could use it. This presents an issue though, because we are not maintaining those tools. Because they're maintained by outside developers, whenever they have updates, we need to integrate them back in and reconfigure the framework to work with them. Depending on how good they are at tracking their updates, they may or may not be. We may have to do some testing to make sure that we don't break the framework. Because if the framework breaks, then we can't talk to it correctly, and the whole thing falls apart. So I was tasked with creating a testing solution for these frameworks to make sure that if we add in new changes to the open source remote access tools, we actually can be assured that they work quickly and efficiently. Any questions on how Rebellion works before I get into testing? No? Okay. I divide testing into 3 main stages. If you Google it yourself, you'll probably find there's a lot more. Some of these go more in depth, some of these break these other ones down into different things. I usually break it down to 3 main stages. The first one is unit testing. Unit testing is testing the individual components. Yes, the frameworks are all written in Python. We'll see the Python code for some of them later. Unit testing is breaking components down into individual functions. So I want to make sure that at the lowest possible thing works first. So let's say I'm making something like a calculator. I want to make sure my add function works. I would do something like test 3 + 2 = 5. Should be true. If I want to test something like division works, I might do 6 divided by 3 = 2. Should work. 6 divided by 0 should give me some relevant error message and be able to fail nicely because you can't divide by 0. And so unit testing is just making sure the smallest pieces work first. Integration testing is now that I know the individual pieces work, do they work together? Can I make sure that they pass the correct things incorrectly? If I'm passing something to a divide function, I want to make sure it's a float and not an integer, so that if I divide 5 by 2, I get 2.5. And if I only pass in integers, I'm going to get 2 out at the end and not the 2.5 that I need. And so this wouldn't work correctly. So just making sure that not only does the function work itself, but does it work as part of a larger whole in interfacing together. System testing is great. Now that I know they work together well, does the whole system accomplish what I need it to? Does it meet the requirements that I need a calculator to do? So it'll be something like I pass it in the string at the top of the calculator now, 2 + 3 + 5 divided by 7 or something. And this should give me whatever that number should be. Security testing is a little outside the stages, but it'll do things like, if it's a static security test, it'll look at the code itself for common code flaws. If you're working in C, this might be something like looking at string length, which is a hazardous function that can cause a lot of buffer overflow issues if not properly handled. And so it'll flag, hey, you're using this function. Are you sure you want to be using this function? And if you are you doing the right things to secure it? Then you have something like dynamic testing, which will be like a fuzzing application, where into my calculator now, instead of putting a legit string of numbers and symbols to make the calculation, I just throw it like 500 A's. Will it break if I throw it 500 A's? If it breaks and crashes, it probably means there's something going on that shouldn't be going on. It should be able to just say, no, you can't do this, and deal with the error correctly. So along with having the different stages, there's this idea of continuous testing. Traditional testing is you build something and then you test it. When you're doing something like programming, though, it might be beneficial to be able to continuously look at something as you're making it to make sure that it's still working. This is the idea of agile development and agile testing with it. So instead of testing at the very end, you test as you go along to ensure it's continuously working. There's a few different principles of this that are important, that it has to be repeatable and reliable. So you should always be able to run the same test and get the same answers. If you run the test and you get different answers, you're doing something wrong, or you're doing something wrong, you need to be able to figure out why. You should always be able to start from scratch and go through the same thing. This test should be automated. If it's not automated, you're relying on someone to manually run it, which could present different issues. Maybe I fat finger something when I run it manually. Maybe I just forget to run it because I'm just developing and I don't have time to test. Happens. It should be built with the end user in mind for quality. It's not enough to just test all the things. You should test for the correct things to make sure that it works as the user intends it to work. And the last thing is shared responsibility. This is the idea that everyone has a stake in the result of the test. Everyone on the development team, developers, testers, everyone should immediately understand when a test runs and it fails, it's up to them to fix it if they added the code in. It's not just, oh, it's the one tester's job to fix everything. No, it's a shared responsibility. If you write the code, and you run the test for it and something breaks, it should be fixed. And so this all leads me to what I'm currently working on now. So I was tasked with creating the testing framework for the testing platform for all the frameworks. And so I picked the open source remote access tool Java Rat, which is a remote access tool written in Java. Clever name. I used a few different tools to do this. GitLab, which uses a Git repository online to implement my continuous testing pipeline. Git, for people that don't know it or aren't familiar with it, is something that tracks file changes and is useful for code collaboration. Docker, which is a platform as a service and uses an OS virtualization to make containers. And these containers will have its own libraries, software, and configuration that are separate from what my computer that I'm running is. So I can spin up a Docker container of an operating system that may not be the one I'm running currently, and it should be a fresh install so that I can do the repeatable and reliable principle of continuous testing to make sure, hey, I start the same every time. And I'm not relying on I don't run into the issue of, it worked on my computer, why isn't it working on yours? It's like, no, if it worked on this from the start, it should be good. And then unit test and PyTest are two Python modules that I use for testing. Unit testing, the unit test module is good for unit testing and is very specific for that. PyTest is a more generalized testing library and works much better for integration testing and probably system testing. Any questions on testing? We'll give it a second this time so I can get water. Okay. So, what I did. Now that we understand what rebellion is, now that we understand what testing is, what did I do? So starting out with unit testing, I want to test the rebellion frameworks at the smallest level possible. So I look at, what I don't want to do is have to stand up rebellion every time I want to run a unit test. I want to be able to be fast and quick with it and not be bogged down by rebellion itself acting up or not being able to run it or something. So instead of running rebellion, I created mock rebellion. What mock rebellion does is it takes the Postgres database that initializes and it fills it with garbage data. So this garbage data I can then use to check to make sure things run properly without having to actually make all this data in the first place. I don't need to go running agents or make tasks or anything like that. I just make garbage data that I can, dummy data that I can use and tag with it. Do I use Selenium Beauty Pursuit? I have not used those, but I've heard of them. I like using GitLab CI/CD because most of the products I use are in Git, and it makes it a lot easier to use GitLab CI/CD pipeline than trying to incorporate something else. So now that I have my mock rebellion that makes my dummy data for me, I can actually continue on and start running the actual unit test that I want. So because I'm running dummy data, I'm not actually testing the functionality yet. What I am going to test instead is if the messages are formed and queued correctly. So when I give the command to the system of, hey, can you get this file from the system for me? Does it have the right number of arguments? Are those the right kind of arguments? Making sure that everything passes through correctly. Does it get queued up in the system correctly, or did we screw that up somewhere? Did someone, when they were coding, forget to add the queuing to it? And so this may sound like, what's the point of this if you're not actually testing if the function works? It's like, well, we're testing the smallest bit first. I'm testing to make sure that's formatted correctly and queues correctly. And then integration testing will test whether it works with the entire system or not. One of the nice things about doing unit test is that it actually does a nice setup and tear down for me, so I don't have to worry about it. And so that I can achieve the repeatable and reliable that I want to each time I run it. So for integration testing, I actually created a class called test client. And what this does, it has the setup, what I would need to set up a client, what I would need to tear down a client to Rebellion. So instead of using Redeye, which is the GUI interface, I actually take the backend for it, and I take what that would then use to program it. Because while it is possible to automatically and programmatically test with GUIs, it is a pain. And I figured at the lowest level I can, we're just going to test whether the functions themselves work, and later on down the line, we'll test to make sure the GUI works. Trying to separate out all the different pieces and parts so I don't get overlapped. So just testing with the backend code to make sure that I can start listeners, stop them, generate deploy payloads command, and kill the agents correctly. And so then these are just the functions behind that gathered together so that it's easy in a test to plug and play with them. Because while I could just take all of these lines as they are and put them into the test each time, I figured it was nice to gather them all together with one command to execute them. So then for integration testing, running the actual tests themselves, I actually do a bottom-up approach, where I'll start with the basics of it and then slowly add on as it goes. And so what this does in an incremental test fashion, it'll test the first function, the second function, the third function. If the third function fails, in this case, test payload, if that one fails, I don't continue on, because there's no need to test the agent if I can't do the payload, because then I won't have an agent. Just how it happens. So if you'll notice, my first function is actually 2 lines, and one of those lines is a print statement. And so it might be confusing of, what is this function even testing? There's nothing here. This one's actually just testing on what's on the left side of the screen in the PyTest picture, making sure that I can just run that correctly. This makes use of the PyTest picture module so that I can take the setup function there, pass it into my other function. Yes, I'm passing a function to a function. And that will actually run setup test beforehand and then use the cleanup at the end of it to make sure that that whole works. And so from there, once I know that I can connect and disconnect, I start and stop the listener to make sure I can do that, test a payload to make sure I can generate it, and then I'll test an agent and make sure I can do a get and a put command from it. So now that I have the basics of my unit testing, my integration testing done, I want to work on continuous testing. Now that I have these, can I do them continuously? So what you'll see here is GitLab's CI/CD pipeline. CI/CD is continuous integration, continuous delivery. And so what I have set up is different stages, and it'll go through each stage and say whether the stage passes or fails, or it passed with a warning, in the case of what the yellow one is. And so this provides an easy interface for developers when they make a code change to make the code change, push the code, and then get immediate feedback on how their code looks. You can change it to run on different things. It doesn't have to run on every time you make a code change and upload it to the Git repository. But the most common way is on every push to the repository, you test the code and give feedback on it. You can set up different things so that some stages are skipped if one fails, some go through, some just give you warnings. I think it's very nice and very configurable, and there's a lot of different things that are helpful. So before I showed the different stages, and so these are what the different stages are. In my build stage, I just make the wheel and the tar file for the framework itself. And this is then used in the syntax stage, where I install this into Rebellion to make sure that the syntax all lines up and Rebellion will accept the wheel and there's no issues there. SAST is static security testing. And this is actually something native to GitLab CI/CD. It's a whole different test suite of different stages to look at for security testing. It does everything from like Python, C, Go, a whole bunch of static code analysis. And then we have the unit and integration stages, which I described before. And then deploy and release. Deploy is deploying something that's the customer is going to use, and release is something we're going to use internally. And so one of the cool things, so on the right side here, we have the YAML file, which is just a markup language. It's the configuration of how I want to run the stages and what's going to be in each of them. So at the top, I have the variable set up, and then below it, each of the stages are defined. Each of the stages are defined with different jobs to run on each stage. So you'll notice for some of these that they say image. The image is a Docker image because what I'm using for GitLab here is a Docker executor. So it's going to take the image I have listed, spin up the container for that image, and I'm going to run everything in that. And so the image I'm using here is actually nice because this is an image from the GitLab server itself where we have Rebellion, and it's going to take whatever the latest Rebellion image is and run that. And so I'm going to run all my code in the latest Rebellion image to ensure that everything works correctly. Because there's lots of issues when you run code, especially in Python, when you install a bunch of different things that sometimes versions conflict. Some things only want a specific version of something. And so making sure that this always works with whatever the latest Rebellion is very handy. And so I never have to worry about, is this going to work with something? Because it checks right here. So getting a little more into Docker itself and what I'm doing with it. In my integration testing, I actually stand up a Docker Compose network. So this, instead of taking one Docker image and making a container for it, this takes two images and makes two containers that I network together. One of these is Rebellion itself with a little extra stuff thrown in, and the other one's the Postgres database. The Rebellion one is actually the one on the left that you'll see here. It's Rebellion with all the Java rat dependencies loaded onto it. So I can make sure that so that I add everything that I need to there, and I can make sure that everything runs correctly from that. So some of the future work that I want to do with this is get to system testing. I didn't get to system testing yet because I need to upgrade my Docker network. Right now, I have it set up that the Rebellion server and the target computer, but I'm also running from the target computer. So it's like my operators and targets are on the same system, and that's not how it's done in real life. So I wanted to upgrade it so I actually have everything spread out, and my Docker network will have an operating system. We'll have where the operators are, where the Rebellion team server is, and where the targets are all set out, all separated out. And then I want to go into filling out more unit integration tests so that I can actually, because I actually did like a depth first search on this instead of a breadth. So I just kind of wanted to do a little bit at each layer to make sure I could do a little bit at each layer before going back, and then I'll go back and fill out the layers. And then the last thing is test red eye, which I mentioned before. We test GUI and actually how that works. Because it's one thing to make sure it works with the backend for it, and it's another thing to make sure that the buttons themselves do what they need to do. Which operating system do I use? I use Ubuntu mostly. It's the one that I was first on. I use Ubuntu for development. I'll say this. I use Ubuntu whenever I'm developing code. It's the easiest one for me to use, the one I'm most familiar with. But for something like this, because these are different, when I actually get to system testing, I'll probably have to change a few of these operating systems to be whatever an operator would use, which is usually like a CentOS thing, and whatever the target is, which could be any number of things. And so I'll have to create a way to test that out. Latest. Lazy. So in summary, I went over myself, I went over Red Team and Rebellion and the work that I've done there, went over my testing efforts with it and the future things that I wanted to work on. Are there any more questions now that we've come to the end of the presentation? I'll preempt the question. These are my cats. Yeah. These are my cats, Artemis and Freya. I don't know if you could hear Artemis crying earlier because I put her in her carrier so she wouldn't bother me during this, but. Individually, I don't know. But it's hard to say individually when we usually work as large teams on things. And so, especially with my work at the 346 Test Squadron, we were testing to make sure that the cyber weapon systems were secure. So that was doing good. I didn't actually get to finish my work there, but we started with the policy for it, and we started coming up with the different mechanisms that we need to put in place, and just putting cybersecurity into testing in the first place, because the squadron itself is very operational test focused. And so we put security testing in as, hey, we need to make sure we include this when we test things, because it'd be bad if we start doing something and we get hacked back. Do they hire people outside the US? I don't know what you mean they, but so yeah, I don't know what you mean by they. Most civilians are US civilians. Yes. I've had a chance to work with international people, but those are usually on different projects. Like, I know for exercises, we get together with some people from the UK and we'll work together on an exercise on different things. So I actually became a technologist in the US Air Force, mostly because my brother did. He joined Air Force ROTC in his college a couple years before I went to college. And I saw that he enjoyed it, and we were very similar people. So I decided to join the US Air Force ROTC as well. And I enjoyed it. I enjoyed the structure for it. I'd always wanted to go into computer engineering. And they were like, hey, we offer scholarships for engineers, and I was like, cool, RPI is expensive. I'll take that. So that was definitely something that I looked into. Yeah, Lockheed is one of the contractors. Work with different contractors a lot of the time. So that's definitely an option if you don't want to join the Air Force as either a military member or a civilian. You can join a contracting company that may or may not work with the U.S. Air Force. Known people that do things like that. Do you have any career advice for the folks participating in this week's hackathon? Do something you like. And don't be afraid to take any opportunities. I didn't think I would like a test squadron much because I didn't know anything about testing. But I thought that once I was there, I found the different ways that I could do things and work on things. One of the other things that we always say is like, do stuff on your own time, find things that you're passionate about. Something like this is great of just, hey, putting yourself out there and trying a Major League Hackathon. So I think you're already doing a great job in putting yourself out there through setting yourself up for a good career. Ah, yes. Where am I going to be in 5 years? The question everyone loves. No, just kidding. So I'm in this program at CNODP for another year. After that, I have a 3-year commitment with them. So I'm hoping to go get my master's, but if not, I'll probably take an instructor position somewhere. I like teaching. I actually was a mentor for a bunch of college students for the past 10 weeks at the ACE program that I mentioned before. When I was in college, I went to the ACE program. And then now I came back to it years later as a research mentor for them, talking about this project actually. I had a bunch of interns with me working on different tasks I set to them for this. So probably a career in teaching cybersecurity or computer science is generally where I want to go next. My job specifically, I'm not sure, but airforce.com for different things that the Air Force is doing. Lots of cool stuff there. Yeah, the time is yours to ask me whatever questions you want. Or I just talk about my cats for like the next hour. Why not? I'm not sure what the question is, but it's great that you're planning for your master's. My favorite type of cat are my cats because they're the best. No, not really, but that's one of those things you don't think about until you actually start coding a whole bunch, is I need to make this so other people can use it. I need to make sure it works. Because especially in something where you're creating cyber capabilities, it's important to know it'll work the first time when you may not have all the information of, may not be able to test it live on whatever system you need to test it on. So all the testing you can do beforehand to make sure that to get as closest to whatever operational environment you want is very important. I do not know any specific. I am not someone that's working with the hackathon. I am a guest speaker they asked to get on. So I am not sure about the specifics of the hackathon itself. Getting started of just the hackathon itself, probably Google. The most useful skill I learned was how to search for information correctly. Beyond any one singular skill was just the idea of going to learn information on your own and making sure that, and being able to find the correct information and use it. Things like Stack Overflow or just tutorials for things have been immensely helpful. And I don't know how to do this thing, but I guess I'm going to have to figure out how. My favorite programming language is probably Python because it's the easiest. And I can do a lot of things with it quickly. But I first learned C++, so that always holds a special place of just, it was the first one I learned that I could do more things than just make a calculator with. I one time made a small computer game in C++, and that was a lot of fun. Of just walking around on a spaceship as the spaceship is falling apart, and you have to go in, fix everything. But Python is probably the easiest language to learn if you don't know any languages, just for the amount of documentation it's on, just for the amount of documentation there is, and that's much more user-friendly. Am I a competitive programmer? No, but I've done things like capture the flag events before, which involve some programming skills, some cybersecurity skills, and those are very competitive. Usually a weekend or 24-hour event of trying to rack as many points as you can on different things.
Hi, folks. Rosendo again. Thanks so much, Captain Laura Curro. You've been so helpful and so informative throughout your time here. Sorry, folks. That's it for questions for now. I just want to thank you once again, Captain, for coming in and addressing our audience. You've been a real pleasure to have. For the time being, we're just going to go ahead and sign off. So, if y'all have anything else to say, feel free to drop it to Discord and ask us some questions there. Some folks from MLH will be around to answer any questions regarding, MLH hackathons and things of that nature. So once again, thank you so much for joining us. It's been great. I hope y'all had as much of a good time as I did, just getting informed about everything that the U.S. Air Force has to offer. Once again, head over to www.airforce.com. That being said, thanks, y'all. Have a good day and enjoy the rest of the hackathon.